sphere. Volume of the sphere is equal to 4 by 3 pi r cube. Surface area of the sphere is equal to 4 pi r square. Volume comes with pi r cube. Surface area comes with pi r square. Volume of a sphere is 4 by 3 pi r cube. Surface area of the sphere is 4 pi r square. Spherical shell, that is a sphere, outer sphere and inner sphere. There is nothing here in between. The thickness of the sphere, spherical shell, is r minus r. This T is equal to r minus r will give the thickness of the shell. Volume of the material here in the spherical shell is 4 by 3 pi. The volume of the sphere is 4 by 3 pi r cube. The volume of this sphere minus this inside sphere will give the volume of the material. 4 by 3 pi r cube minus r cube. 4 by 3 pi r cube minus 4 by 3 pi r cube. We have taken 4 by 3 pi common, r cube minus r cube. Hemisphere, half of the sphere. Volume of the hemisphere is half of the whole sphere. The whole sphere, volume of whole sphere is 4 by 3. Half of that is 2 by 3 pi r cube. The curved surface area is equal to 2 pi r into r. Curved surface area. This curved surface area is 2 pi r. If you take this as radius or length, we can take it as 2 pi r square. Curved surface area of hemisphere is 2 pi r square. Or and total surface area is equal to this curved surface area plus the area of this circle, that is 2 pi r square plus pi r square, that is 3 pi r square. The volume of the hemisphere is 2 by 3 pi r cube. The curved surface area of the hemisphere is 2 pi r square. Total surface area is equal to 2 pi r square plus pi r square, that is 3 pi r square. Find the volume and surface area of the sphere whose diameter is 21 centimeter. The volume of the sphere is given by 4 by 3 pi r cube. Pi 4 by 3, 22 by 7. The diameter they are given it as 21, therefore r is equal to d by 2, 21 by 2 into 21 by 2 into 21 by 2. When you calculate volume, we are going to get 4851 centimeter cube. Surface area of a sphere is given by 4 pi r square. 4 into 22 by 7. R is d by 2, that is 21 by 2 into 21 by 2. That gives 1386 centimeter square. The volume of the sphere is 36 pi centimeter cube. Find the surface area of the sphere correct to nearest centimeter square. Volume, they have given it as 36 pi centimeter cube. We need to find out surface area. We have the formula for surface area as 4 pi r square. So in this, to find out the surface area, we don't know r. So they were given volume. Volume is equal to 4 by 3 pi r cube. They were given the volume so that we can find out r. Volume is 36 pi, that is equal to 4 by 3 pi r cube. This pi got cancelled. 36 into 3 divided by 4 will be r cube. Therefore r will be 3. Therefore surface area is equal to pi r square. 4 into 22 by pi. 3 into 3, that will give 113.14 centimeter square. We are keeping it to nearest is 113 centimeter square. A solid sphere of radius. A solid sphere of radius r is equal to 15 centimeters is melted and recast into solid right cones. Each of radius r is equal to 2.5 centimeters and height 8 centimeters. Calculate the number of cones recast. See, we have melted solid sphere of radius 15 centimeter and made into cones of radius or radius 2.5 centimeters and height 8 centimeters. we need to find out how many cones we have made out of this solid sphere. So we made from this sphere the cones. Therefore, the volume of the sphere will be equal to volume of cones. The volume of the sphere is equal to n is number of cones into volume of cone. So that is equal to volume of sphere is equal to volume of cones, number of cones formed. The volume of sphere is given by 4 by 3 pi r cube, that is equal to, this is number of cones into volume of a cone, 1 by 3 pi r square h. So this is important point here. Once you write this, rest is simple calculations. 4 by 3, this pi get cancelled, r is 15, 15 into 15 into 15, n we need to find out, that is number of cones, 1 by 3, r is 2.5 is 5 by 2, 5 by 2 into h is 8 they have given. This will become 4500 into n into 50 by 3, therefore n is equal to 4500 into 3 divided by 50, therefore number of cones formed n is equal to 270. See, here the sphere we converted into the cone of these dimensions. So the volume of this is equal to the volume of the cones formed. We need to equate that. Then write the formulas and find out the value of number of cones. A hollow sphere of internal radius and external radii 6 centimeters and 8 centimeters respectively is melted and recast into small cones of base radius 2 centimeters and height 8 centimeters. Find the number of cones formed. This is the same as the previous problem. Only thing is here the hollow sphere is cast into the cone. The hollow sphere with internal radius of 6 centimeters and external radius of 8 centimeters is cast into the cones of radius 2 centimeters, height 8 centimeters. We need to find out how many cones we have made out of this hollow sphere. Here once again the volume of the hollow sphere is equal to the number of cones formed. So we are not adding any extra material. Whatever was there we melted and recast into the cones. Therefore the volume of the hollow sphere is equal to the volume of the cones formed. The volume of the hollow sphere is equal to the volume of the cones. Number of cones is represented by n. The n into one volume of one cone will give the volume of the cones. The volume of the hollow sphere is 4 by 3 pi r cube minus r cube, that is equal to n into volume of cone 1 by 3 pi r square h. This pi got cancelled. 4 by 3, this r is 8 cube minus 6 cube, that is equal to n into 1 by 3, 2 into 2, r square is r, 2 into 2 into h is 8, that will give 512 minus 216 is equal to n into 8, 2 to the 4 cancel, this 3 got cancelled, therefore n is equal to 37. Number of cones formed is equal to n is equal to 37. By using this hollow sphere, we made 37 cones of radius 2 centimeters and height 8 centimeters. A semicircle bowl of diameter 7.2 centimeters is filled completely with chocolate sauce. This sauce is poured into an inverted cone of radius 4.8 centimeters. Find the height of the cone. So we have poured the chocolate into a hemispherical bowl and we transferred the chocolate into a cone of radius 4.8 centimeters. We need to find out the height of that cone. The diameter of this hemispherical bowl is given by 7.2 centimeters. Therefore, or radius of that bowl is 7.2 divided by 2, that is equal to 3.6 centimeters. When you are pouring the chocolate from hemispherical bowl to the cone, the volume of this is equal to volume of this. Therefore, volume of hemispherical bowl is equal to volume of the cone. Volume of hemispherical bowl is given by 2 by 3 pi r cube and volume of cone is given by 1 by 3 pi r square h. This pi got cancelled, so this is going to be 2 by 3. This r is given by 3.6 into 3.6 into 3.6. So 1 by 3, 4.8, or this r is our radius of the cone is 4.8 into 4.8 into h. So this we got cancelled. So we, after calculations, we got it as h is equal to 4.05 centimeters. This is the height of the cone. We need to equate the volume of hemispherical bowl with that of the volume of the cone and use the equations of the volumes of both and substitute the values. You need to be careful here. This is the radius of the hemispherical bowl. This is the radius of the cone. Here you may do mistakes. So you have to substitute the exact values of sphere here, the cone here. Rest is simple calculations. The given figure represents a hemisphere surmounted by a conical block of wood. The diameter of their bases is 6 centimeters each. The diameter of the hemisphere and that of the cone is 6 centimeters each, and the slant height of the cone is 5 centimeters. We need to calculate the height of the cone and the volume of the total solid, or the volume of this. We need to find out h of a cone, volume of this total, that is V1 plus V2. Diameter, they have given it as 6 centimeters, therefore radius will become 3 centimeters. Slant height, they have given it as 5 centimeters. We need to find out the height of the cone and the volume V1, the volume of the hemisphere plus the volume of the cone. So we can find out h using L square by using this Pythagoras theorem. L square plus h square, r square plus h square, therefore h is equal to square root of L square minus r square. This is 5 square minus 3 square, that will become 4 centimeters. The height of the cone will become 4 centimeters. The volume is equal to volume plus V1 plus V2. V1 is the volume of the hemisphere, that is 2 by 3 pi r cube. Volume of the cone is 1 by 3 pi r square h. So we can take it out, 1 by 3 pi r square as the common. The 2r is left out here plus h. Substitute the values, 1 by 3, 22 by 7 into 3 square. This is 2 into 3 plus 4. After calculations, we got the volume of this whole solid is 94.29 centimeter cube. A solid cone of radius 5 centimeters and height 8 centimeters is melted and made into small spheres, each of radius 0.5 centimeters. Find the number of spheres formed. Solid cone of radius 5 centimeters, height 8 centimeters, melted and made into the small spheres of radius 0.5, that is equal to 1 by 2 centimeters. We need to find out how many spheres we made of this out of this solid cone. See, we made these spheres with the volume of this. Therefore, volume of the solid cone is equal to volume of the spheres. Volume of the cone is equal to volume of the spheres. Volume of the cone is 1 by 3 pi r square h. Volume of the spheres is equal to volume of one sphere into number of spheres. N into n is number of spheres, that volume of sphere is 4 by 3 pi r cube. 1 by 3, 3 got cancelled, pi got cancelled. R square is the radius of the cone. 5 into 5 into 8, n we need to find out, 4 r cube. R is 1 by 3, that is the radius of the sphere. 1 by 2, 1 by 2, 1 by 2. Therefore, n is equal to 5 into 8 divided by 2. This 4 got cancelled with this 2. Therefore, n is equal to 400. Number of spheres is equal to n is equal to 400. So we converted solid cone of radius 5 centimeters and height 8 centimeters into 400 spheres of radius 1 by 2 centimeters. The surface area of a solid metallic sphere is 1256 centimeters square. It is melted and recast into solid right circular cones of radius 2.5 centimeters and height 8 centimeters. Calculate the radius of the solid sphere, the number of cones recast. The surface area of the solid sphere, they have given it as 1256 centimeters square. They have melted this solid sphere and recast into cones of radius r is equal to 2.5 centimeters. The height of that cones are 8 centimeters. We need to find out the number of cones recasted, and the radius of this sphere. That means we have melted this sphere and made into cones. Therefore, volume of the sphere which melted and we made into cones are equal. They have given surface area is equal to 4 pi r square. So to differentiate between this radius of this, we are taking this as a capital R and this as a small r, so that we should not have any confusions. So surface area, they given it as 1256, that is equal to 4 into pi is 3.14 into r square. R square is equal to 1256 divided by 12.56, that is equal to 100. Therefore r is equal to 10 centimeter. The radius of the solid sphere is 10 centimeters. So we recasted this solid sphere into cones. Therefore volume of the sphere is equal to volume of the cones formed. Volume of the sphere is equal to number of cones formed into volume of a cone. The volume of the sphere is given by 4 by 3 pi r cube, that is equal to n into volume of the cone is 1 by 3 pi r square h. That is this 3 got cancelled, pi get cancelled. 4 into 10 into 10 into 10, r into r into r. That will give n into r square is 2.5 into 2.5 into 8. 4000 is equal to n into 50. So therefore number of cones recast is equal to n is equal to 80. By using this solid sphere of surface area 1256 and radius 10 centimeters, we recasted the cones of radius, recasted 80 cones of radius 2.5 centimeters and 8 centimeters. A cylindrical vessel of radius 4 centimeters contains water. A solid sphere of radius 3 centimeters is lowered into the water until it is completely immersed. Find the rise in the water level in the vessel. This is a cylindrical vessel of radius 4 centimeters. There is some water inside this. So we have immersed a sphere of radius 3 centimeters into the water. We immersed. Because of this immersion of the sphere, the water level increased from here to here, from here to here. That means the rise in water, the volume of rise in water is equal to volume of the sphere. Find the rise in water level in the vessel. We need to find out the volume here increase is equal to the volume of this sphere. Volume of raised water is equal to the volume of the sphere. This is V1. This is the volume of the raised water. That is, this is a cylinder. This is the volume of a cylinder is pi r square h. And the volume of the sphere which is immersed 4 by 3 pi r cube. This pi got cancelled. This r is the volume of this cylinder. R is 4 square. 4 into 4 into h. H is the rise in water, that is equal to volume of the sphere 4 by 3. Radius of the sphere is 3 into 3 into 3. Therefore this 4 got cancelled, this 3 got cancelled. 4h is equal to 3 3s are 9. Therefore h is equal to 9 by 4. H is equal to 2.25 centimeters. The rise in water level is 2.25 centimeters. This rise in water. So what we did here is, so we equated the volume of this sphere. Because we have put this sphere inside the water, there is increase in the volume of water inside the cylinder. So we are equating this volume of increase in the cylinder equals the volume of the sphere. So equate the formulas of the volume and substitute the specific values. This r radius of this r is the radius of the sphere. The rest is simple calculations. In these problems, we need to understand the problem. The rest becomes very easy. Marbles of diameter 1.4 centimeters are dropped into a beaker containing some water and are fully submerged. The diameter of the beaker is 7 centimeters. Find how many marbles have been dropped in it if the water rises by 5.6 centimeters. There is a beaker. Inside that beaker there is some water. We have put some marbles inside that, which has got the diameter of 1.4 centimeters. We need radius, therefore radius is equal to d by 2, that is 0.7 centimeters. So the radius of the marbles which are immersed in this beaker which contains some water. So because we immersed so many marbles, so the water level increased in the beaker is 5.6 centimeters. To make this change in the water level, we need to find out how many marbles we have put inside the beaker. That means the rise in this thing, that rise means that is a volume increase in volume of water will be equal to the volume of the marbles we have put inside the beaker. That is simple. Once you know this, you equate this volume with the volume of the marbles, the rest substitution and calculations. We need to understand the problem, then rest automatic. Marbles of diameter 1.4 centimeters are dropped into a beaker containing some water and are fully submerged. The diameter of the beaker is 7 centimeters. Find how many marbles have been dropped in it if the water rises by 5.6 centimeters. We need to equate these two volumes. V1 is equal to V2. Increased volume of water in the beaker is equal to volume of the marbles which we have put into the beaker. The increased volume of water is equal to pi r square h. R is the radius of the beaker. The h is the increase in the volume, height of this water. N is number of marbles which we may put into the beaker to increase this height into volume of each marble. Pi r square h is equal to n into volume of marble is pi by 4 by 3 pi r cube. Marble is nothing but a sphere. 4 by 3 pi r cube. This pi got cancelled. R square, or they given it as 7, the radius of the thing, 7 by 2. The diameter is 7, therefore the radius is 7 by 2. The diameter is 7, the radius is 7 by 2. 7 by 2 into 5.6, this is the rise in water, that is equal to number of marbles into the volume of each marble, 4 by 3. 0.7 into 0.7 into 0.7, that is equal to 7 into 7 into 5.6 into 3 divided by 2 into 2, 4 into 0.7 into 0.7 into 0.7, that is equal to 150. Number of marbles dropped into the beaker is 150. We have dropped 150 marbles to increase the height of the water is equal to 5.6 centimeters. We need to equate the volume of the marbles with the volume of the water raised, then we can find out the number of marbles which we have put it into the beaker. A solid consisting of a right circular cone standing on a hemisphere is placed upside in a circular cylinder. It is placed inside the cylinder full of water and touches the bottom. Find the volume of the water left in the cylinder. We need to find out the volume left after we immersed the solid inside the beaker. What is the water left out inside the cylinder? Having given that the radius of this cylinder is 3 centimeters, the height of that is 6 centimeters, the radius of the hemisphere is 2 centimeters, the height of the cone is 4 centimeters. So we need to find out how much water is left out. This is the solid with these specifications. Radius of this is 2 centimeter, height of the cone is 4 centimeters, and the cylinder with full of water with radius is 3 centimeters and height is 6 centimeters. When immersed inside, this solid is immersed this inside, what is the amount of water it is left out? So that can be done. V3, this is the V3 volume of water left out after this is immersed. V3 is equal to V2, that is the water before the immersion, minus this V1. This much, this volume, whatever the solid volume, that much of water is flown out. The rest is V3 is equal to V2 minus V1 will give the water left out after immersion. Let us find out the volume. We need to deduct volume of this with this water, because that much of volume of water is flown out of this when it is immersed inside that. we need the volume of this. Volume V1 is equal to volume of the sphere plus the volume of the cone. What is the volume of the sphere? 2 by 3, this is hemisphere, 2 by 3 pi r cube. R is 2 centimeters, r cube, plus 1 by 3 pi r square h. R square is 2 square h, that is equal to 32 pi by 3 centimeter cube. This is the volume of this solid, combination of cone and the hemisphere. Volume V1 is equal to volume of sphere plus volume of cone. This is required in the later stages. Then volume, the total water which was there before immersing this, the volume of water in a cylinder V2 is equal to pi r square h, that is equal to pi into 3 square into 6, h is 6, that will become 54 pi centimeter cube. Water left in the cylinder after placing the solid into it is V3 is equal to V2 minus V1, because this much of water has flown out, then left out is V3, that is V2 minus V1. V3 is equal to, V2 is given by 54 pi, V1 is given by 32 pi by 3. V2 minus V1, V3 is equal to V2 minus V1, that will become 132 by 3, that is equal to 136.19 centimeter cube. This is the amount of water left after the immersion of this solid. So what we did, we calculated the volume of this solid, we calculated the volume of water, and finally we deducted volume of solid with this original volume of water to get the remaining volume left in the beaker. A toy is in the shape of a right circular cylinder, with a hemisphere at one end and a cone on the other end. The height and radius of this cylinder is, height is 13 centimeters, the radius is 5 centimeters. The radii of hemispherical and conical part, the radii of this and this conical part is same as that of the cylindrical part. Calculate the surface area of the toy. We need to calculate the total surface area of the toy and volume of the toy, and we need to find out the volume of the toy. If height of this cone is 12 centimeters. So to find out the curved surface area, we need to find out the curved surface area of this hemisphere and this cylinder and this cone. The curved surface area of this hemisphere is 2 pi r square, or is same for this hemisphere, cylinder and cone. 2 pi r square for this cylindrical part, 2 pi rh curved surface area for this is pi rl. So this will give the curved surface area of the toy. Curved surface area of the toy is equal to curved surface area of the hemisphere and cylinder and cone. Curved surface area of hemisphere is 2 pi r square, that of cylinder is 2 pi rh, that of cone is pi rl. Then we taking out pi r as common, then 2 into r, 2 into 5 plus 2 into h, 2 into 13 plus L is, we calculated using L is equal to square root of 5 square plus 12 square, r square plus h square, that will give 13, that is 5 pi into 10, r is 5 pi, 5 to the 10, 26 plus 13, that will give 245 pi, that is pi is 22 by 7, that is equal to 770 centimeters square. This is the curved surface area of the whole tie. Then we'll go to the volume. Here volume also, volume of this hemisphere and volume of this cylindrical part and volume of this cone. Therefore volume is equal to 2 by 3 pi r cube of this sphere, then pi r square h of this cylinder, 1 by 3 pi r square h of this cone. So 2 by 3 pi 5 cube, pi 5 square 13, 1 by 3 pi r square is 5 square into height is 12. So we get volume is equal to 1525 pi after calculations, that is equal to 1525 into 22 by 7. The total volume of the toy is 1597.6 centimeter cube. The outer and inner diameters of a hemispherical bowl are 17 centimeters and 15 centimeters respectively. Find the cost of polishing it all over at 50 paise per centimeter square. This is a bowl with outer diameter as 17 centimeter, outer diameter 17 centimeter, inner diameter is 15 centimeters. We need to find the cost of polishing for the whole thing with 50 paise per centimeter cube. Therefore, we got it from this values they have given. The inner radius is 15 by 2, outer radius is 17 by 2. The total area to be polished is, this is the inner surface area of the inner surface, and the outer ring, and the top ring, this part, and the area outside ring. These to be polished. Area of the inner surface and the area of this top ring and the area of this. So total area to be polished is A is equal to A1, A2, A3, A1 plus A2 plus A3. Inside surface area 2 pi r square, this part, the strip, that is equal to pi r square minus r square plus outside 2 pi r square outside. Then we are taking pi as common, 2 times r square 15 by 2 whole square, then pi we are taken out, r square, that is 17 by 2 whole square minus 15 by 2 whole square plus 2 times 17 by 2 whole square. Pi into this will give 225 by 2 plus 16 plus 289 by 2, that will give 858 centimeter square. This is the total area to be polished. They are given, that is, there is cost of polishing is 50 paise per centimeter square. The total area multiplied by 50 paise, convert it into rupees. 858 into 0.5 rupees, that will give 429 rupees to polish this bowl. So we have calculated the area inside this, then the area of this strip ring and area outside this. So we multiplied that area with the cost. We got finally 429. A certain number of metallic cones, each of radius 2 centimeters and height 3 centimeters, are melted and recast into a solid sphere of radius 6 centimeters. Find the number of cones. There were cones that were melted and recast into a single sphere of radius 6 centimeters. The cones of radius 2 centimeters and height 3 centimeters. We need to find out number of cones were used to make one sphere. Therefore, volume of the cones is equal to the volume of the sphere. N is the number of cones used to make sphere into volume of each cone, that is equal to volume of the sphere. N is number of cones, volume of cone is 1 by 3 pi r square h, that is equal to 4 by 3 pi r cube. N into 1 by 3, the pi get cancelled. 2 into 2, this radius of the cone, 2 into 2 into 3, 4 by 3, 6 into 6 into 6. After calculations we got number of cones used to make a sphere of radius 6 centimeters is 72. Two solid spheres of radii 2 centimeters or 4 centimeters are melted and recast into a cone of height 8 centimeters. Find the radius of the cone so formed. We use two spheres of radius of one sphere is R1 is equal to 2 centimeters, R2 is equal to 4 centimeters. We use two spheres to cast a cone, melted and cast into a cone of height 8 centimeters, and we need to find out the radius of the cone. So because we use two cones, the volume of these two cones will be equal to the volume of the cone formed. Volume of the spheres is equal to volume of the cone. there are two spheres, there we will be adding two volumes. 4 by 3 pi r1 cube plus 4 by 3 pi r2 cube is equal to 1 by 3 volume of the cone pi r square h. Then we are taking out 4 by 3 pi outside. 4 by 3 pi r1 cube plus r2 cube is equal to 1 by 3 pi r square h. This 3, this pi, this 3, this pi got cancelled. 4 into r1 cube is 2 cube, r2 cube is 4 cube is equal to r square into h. The height of the cone is this. Therefore, r square is equal to 72 by 2, that is equal to 36. Therefore, r is equal to 6 centimeters. Therefore, the radius of the cone is so formed is 6 centimeters. The surface area of a solid metallic sphere is 2464 centimeters square. It is melted and recast into solid right circular cones of radius 3.5 centimeters and height 7 centimeters. Calculate the radius of the sphere and the number of cones recast. The sphere with surface area 2464 are melted and recast into the cones of radius 3.5 centimeters and height 7 centimeters. We need to find out how many cones we made out of this sphere, and also we have to find out the radius of the sphere. We know that the volume of this sphere is equal to volume of the cones formed. So because they have given the surface area, we can find out using the formula of surface area, the R. Surface area is equal to 4 pi r square of the sphere. That is, they have given us 2464, that is equal to 4 into 22 by 7 into r square. R square is equal to 2464 divided by into 7 divided by 4 into 22. That will give r is equal to 14 centimeters. This is the radius of the sphere. This sphere we cast into the cones. Therefore, the volume of the sphere is equal to volume of the cones formed. Volume of the sphere is equal to volume of the cones. N is the number of cones so formed. Volume of the sphere is equal to 4 by 3 pi r cube is equal to n into volume of the cone 1 by 3 pi r square h. This pi got cancelled, 3 got cancelled. 4 into 14 cube, that is the radius of the sphere. That is equal to number of cones into 7 by 2, 7 by 2. This is the radius. 3.5 can be written as 7 by 2. 7 by 2 into 7 by 2 into h is the height of the cone. Therefore, n is equal to 128. The number of cones recast is equal to 128 cones.